basically, if it's a prime number, then it's not a composite. If it's not a prime, it's a composite, right? I put an example up there, the number 12. Obviously, you can see that 12 can be divided by more than two different numbers, right? You can divide it by the number 2 and get 6, divide it by the number 3 and get 4. Those are all different factors making it a composite number. Great. What about the number 1? Who knows if the number 1 is a prime or a composite number? What's it called? Number 1. Is it prime or composite? Tell me the factors of 1. Are there any other factors?
No.
There's only one factor. You would think it's prime, but prime numbers need to have only two factors, right? This only has one factor. Kiva.
Neither?
It's neither. It's what we would like to call special. We refer to the number 1 as special. So it's very special. It's neither a prime nor a composite, and it doesn't really fit in with either rule. So if you look at the definitions that we had for the prime number, in both of them actually, we included greater than 1, right? Greater than 1. So always be careful with the number 1. I got a bucket up here with numbers 2 through 65 in here, and I want someone to come up here and pick one out for me. Come on. Read it out. 57. You want to return your seat? Raise your hand if you think 57 is a composite number. Don't be shy. If you think it's composite, raise your hand. Raise your hand if you think it's a prime number. If those of you who think it's a composite number, tell me why it would be a composite number. This is actually a really tricky one. So one, tell me.
Because it's not a prime number.
Well, what would tell you that it's not a prime number? It would have to have more than what?
Because 5 isn't a prime number?
Well, we're talking about the number 57, right? Can somebody tell me the factors of 57?
Because it doesn't have to have two factors.
Well, if it only has two factors, it would be what? 1 times 57. That would make this a prime number, right? If it's only got two factors, 1 and 57. The tricky thing with the number 57 is the number 3 is a factor. 3 times 19. Is this now a prime or a composite number? Raise your hand if you think it's a prime number. Raise your hand if you think it's composite. Raise your hand if you don't know. You're not sure. Okay, well, if you're not sure, we'll keep on going. I need another person to come up and draw another number. Okay. Or pick a smaller number. Let's just get
57. Oh my god.
Put it on the side.
Yeah.
61.
61. Okay. 61 is another huge number. Raise your hand if you think 61 is a prime number. Raise your hand if you think it's composite. If you think it's composite, tell me another factor other than 1 or 61. This only has two factors. So if a number only has two factors, is it prime or composite? Prime. All right, let's try to get another example up here that's a little bit easier. Okay, this one. That's it.
Choose a small one. 31.
31. Okay, one more time. Raise your hand if you think 31 is a prime number. Raise your hand if you think it's composite. Raise your hand if you don't know. Okay, 31 is a prime number. There's only two factors, 1 times 31. So I think you guys are kind of getting the idea here. Okay, we'll do one more number. Okay, some other quiet. Okay, Alexis. One last one. Hopefully it'll be a smaller number.
We read the bucket. 2. 4.
4. That's a good one. A really easy one. Is 4 a prime or a composite? Raise your hand if you think 4 is a prime number. Raise your hand if you think it's composite.
Ooh.
Raise your hand if you're not sure. Okay, good. This is a composite number. I'm glad that everyone is pretty comfortable with that one. So let's take a look now. How did we find out if numbers were prime? Someone tell me one method that we use to determine if a number is prime. Tell me.
If it's prime, it would
how do we determine if a number, like, what was the last number we used? Number 4.
1.
How would you determine, how did you guys decide if 4 was a prime number? What method did you use?
Because the 3 had more than 4, I mean 2 factors.
Well, you knew that it had how many factors? 1 and 4, right? And 2 and 2. Well, we don't have to write twice. So we use the factors to find out if a number is prime or composite, right? That's pretty good. So you could take any number and find the factors and determine if it's prime. For like example, the number 16, prime or composite? Prime? Why is it composite? Tell me one of the other factors. Well, other than 1 and 16. 2, 4, and 4. Great. So you can use factors to find out if a number is prime or composite. That's one method, right? We can use factors. What's another way you guys think we can determine if a number is prime or composite? Okay, we could do that. That's the rule of 2's, right? Rule of 2's. And what are the rule of 2's? Is that we can look at what number to tell. Someone give me a 3-digit number real quick. What's it? 3 digits, 3 numbers. Go ahead, tell me 3 numbers. 3 numbers off the top of your head.
1, 2, and 3.
1, 2, 3. Can the number 2 divide into number 123? How would you know right away? You should be able to tell right away. What's the clue?
It's the 3.
Is it an even number or an odd number? Odd. So would the number 2 divide into? Gotta be an even number. If it's an even number, what number does it end in? If it is an even number.
2, 4, 6, 8, or 0.
Very good. So that's another way you can do it. We use called rule of 2's. Can someone think of another way to determine if a number is prime or composite, other than Jose Juan? Anybody else? Okay, fine. Tell me what you got.
If it's a composite, you can divide it.
Okay, so take the number 16, right? We can divide it by what number? Tell me a number.
2.
2. 2 divided by 16 is equal to what? We have 2 here. 0, right? Bring down the 1. 2 goes into 16 how many times?
8.
8. So you can divide. Dividing is another way.